Okay, class. Hopefully now we can put it all together. What can we do? We can put it all together as to how you breathe in and out. All right. Let's examine this picture right here, then we'll look at that. Okay. Let's assume right now that you are at sea level. Therefore, the atmospheric pressure is around 760 millimeters. Okay? About 760 millimeters. Okay? Now, per cubic inch, let's say, per cubic inch. Okay, let's say now that here's the thoracic wall, here's the parietal pleura, here's the visceral pleura, here's the space between the two, which is the pleural cavity. That space there. All right. Now, so this space here, the pleural cavity space, can be called the pleural space, intrapleural space, or some will call it the intrathoracic space. Okay, pleural space. We got to know our areas. This is inside the lumen of the trachea and the bronchi. This right here is the space inside the lung. Okay, this would be the intrapulmonary space, we could call it, inside the lung. Intrapulmonary. All right. Now, this is how we're going to look at this thing. Okay. So, right now, let's say your mouth and nose are open and you're not breathing in or out. So, let's just start. You're not breathing in or out. That means that you have equilibrated your atmospheric pressure with the pressure inside the lung. All of it's now equilibrated. So right now, let's say it's 760 here, 760 here, and 760 here. Nose and mouth open, not breathing in and out. So 760 all the way down. Okay? So that's where we are. Now that's inside the lung. Intrapulmonary, 760. Now, I want to look at the space now, right here. Now this goes also with Boyle's law. The natural tendency of the chest wall is to pull out. See, that's where I have here. The natural tendency of the chest wall is to pull out. Why? Due to the rib and muscle design. So that pulls out. The natural tendency of the lungs are to pull in. Why? Because of the surface tension of water and elastic fibers. So the natural tendency of the lungs is to pull in, and the natural tendency of the wall, again, you're sitting there resting, nose and mouth open, pull out. That makes a space in here, kind of a larger space. Because this is a closed-in bag, larger space, let's say large space, then the pressure in here, Boyle's law, is about 4 millimeters of mercury pressure below that in the lung and below that that's out here in the atmosphere, because of that tendency to pop out and the lungs' tendency to pop in. Okay, right here. All right, so about 756. Okay, but in here about 760. All right, now we're getting ready to inhale. Okay, so we have the players in. We're getting ready to inhale. Your chest wall muscles and the diaphragm would expand the chest. Diaphragm comes down, external intercostals move out. What will first happen is this number here will drop about 2. It'll drop about 2 to about a 754. Why? Because you're expanding out that chest. So I'm going to say that's going to drop to a 754. Now, if that drops to a 754, what does this do? Drop to a 758. That would drop 2. You drop 2, you drop 2. 758. What happens then? Basically, because of the compliance of the lung, change in volume over change in pressure, we drop 2. But the key is if you're 758, you're less than 760. So air rushes in. How much air rushes in? Well, if we use this chart, again, like I said, difference in people, 500 cc's, because that would be your tidal volume. So by dropping that 2, 500 cc's came in. Again, let's go back. The skeletal muscles expanded the chest. You originally had a 756 in the intrapleural space because of the natural tendency of the chest wall to pop out of you to pop in. When you expanded the chest out more because diaphragm dropped and external intercostals, you went to generally a 754. Now that's with quiet breathing, ladies, and eupnic breathing. This is just what you're doing now. When you went down two, because you pulled out on me because of the water tension. You kind of pulled out. That went to a 758. When that went to a 758, it's less than this, so air rushes in. So now, right now, you have an extra 500 cc's of air in there. How do I get, so that was inhalation. How do I get it out? Just let those muscles relax. Just passively let them relax. Okay? What would have happened? Now let's go back. You see, when the 500 cc's rushed in, that brought you back to 760. But you got to 760 with an extra 500. That then pushed on you to make you back to 758. So with that 500 cc's I just brought in, I got back to 760 and you got back to 758. But I'm expanded out with air in me. I'm going to let the muscles relax. When the muscles relax, you compress in, you push up. What does that happen? Now you were 758 with that extra 500. Now you're going to go up because you were 758, right? And you right here was 7. So now you press in. You go to what? 760 because you were 758 again. I'm sorry, you were 756 again. You were 756 again with extra 500 cc's. When you compress down, you go to 758. When you go to 758, you go to 762. When you go to 762, you're above this and air rushes out. So let's do it one more time to be sure we're on target. Nose and mouth open, nothing happening. You're equilibrating at 760 all the way down, but the intrapleural space is a 756, about 4 less than what's in here because the chest wall likes to pop out and the lungs pop in. Now you drop the diaphragm, you're inhaling, and the external intercostals come out. When that occurs, you first, since you're the one that pulled out, go to 754. You were 750. When you went to 754, you went to 758. When you went to 758, you were less than this, and you brought 500 cc's in. Why? Because that's the compliance of the lung, the average stretch of the lung. That's your tidal volume, let's say. Now you got 500 cc's in there, which brought you back to 760 and brought you back to 756, but with an extra 500 cc's. Now you get ready to breathe out. All you do is let those muscles go. And what happens then, this pushes in, takes you to 758. When you go to 758, you go to 762. You're above this and air comes out. And that's how you're doing it. Now, if you want to bring more air in than usual, then you're going to start to use those other muscles, the scalenes, the pec minor and everything. And you're going to start maxing out the diaphragm. Now you say, what does that mean? Normally, remember the diaphragm was 10 centimeters. Under quiet breathing, you only drop it 1. Under quiet breathing, you generally only drop it 1. Say it again. Under quiet breathing, you only drop it 1. This dome-shaped muscle. Only drop it 1. But if you want to do hyperpnea, which is deep breathing, then you're going to bring it down further. You're going to expand the external intercostals out further, and you'll start bringing those other muscles in. Now, if you bring it all in, drop you all 10, max out the external, and bring all those others, and you do everything, then you would bring all of this in. All of that in, because these pressure changes would be more tremendous. Now again, Since you brought all that in, you just let all that massive group of muscles relax. That compresses down and it all comes out. So you brought it all in, but it brought it all out down to where? Down to here. Down to here. So you let out your inspiratory reserve and your tidal volume. Okay? Now, if I want to force air out, which means going down here after the tidal volume, then what I'm going to have to do is squeeze down on the chest. Squeeze down on the chest, which means now I'm going to have to bring in the sit-up muscles to squeeze down. I'm going to have to bring up the sit-up muscles, and I'm going to have to invoke the use of the internal intercostals, which I normally never use. So I'm going to bring these in and the sit-up muscles. Rectus abdominis, external, internal obliques, transversus abdominis. And what that would do is force this air out down to this level. This is the level we never want to let out. So that's how you breathe in and out. Now, you will see I'll have two videos, not mine, two videos, kind of a little more motion. They'll kind of help you with this. They'll kind of help you with that activity there. But that gives you an understanding of how you breathe in and out using this particular aspect there. Now, I want to go to another thing there too. This is more pathology. All right. Look here. You are 756. Right here, you're 760. Now, this is what we call a sucking chest wound. Okay. If I assumed, let's say I let 760 equal 0. Let's say I let 760 equal 0. Now, this is like a math thing. Then you would be less than 0. If I let 760 equal 0, you would be less than 0. Just like out here, you would be less than this too. You'd be 4 less. So you have a negative pressure in here if we do it that way. A negative pressure in here. Now, if that's the case, if you were the unfortunate recipient of a knife wound, a stab wound, that pierced here, that somebody stabbed you right there, that means pierced through here, then air at 760 would rush in. Air would rush in. That's what we call a sucking chest wound. The technical name for that is a pneumothorax. The technical name for that is a pneumothorax. I'm going to try to put that for you real quick. The technical name for that is a pneumothorax. Pneumothorax. You can look this up. The technical name is a pneumothorax. But some will call it a sucking chest wound. Okay? Now, that's a traumatic one. I just named a traumatic one. Sometimes these alveoli, you can have weak alveoli. Let me see if I can find a picture of the lung real quick. Sometimes you can have weak alveoli. See right here, that's the lung. See those little bumps there? The lung has little bumps on it, and those are the alveoli, I wish I had a better picture, close to the surface. So alveoli, 300 million, but some of them are very close to the surface there. I don't have another picture that would give this bumpy appearance to the lung. Sometimes they just blow out, one of them right there. And that's what we call a spontaneous pneumothorax, both of which would cause the lung, part of the lung, to collapse. And the fancy name for a collapsed lung, I'll put another term up here real quick. The fancy name for a collapsed lung, if I can get it to do it, is called atelectasis. So atelectasis, another word to look up. Atelectasis. Atelectasis is a fancy word for collapse of part of the lung. So I just wanted to show you that that's what a sucking chest wound is, they'll say. That the person got stabbed and had a sucking chest wound because this intrapleural pressure is less than the atmospheric, and air could rush in and collapse the lung. That's a traumatic one, or if somebody said they threw a spontaneous pneumo, that's when one of these alveoli popped. Okay, so we'll close here.